So today, we're talking about applications of radical functions or square root functions, either way. So let's look at this first one. So this one says the number of people, which is y, involved in recycling in a community can be modeled by this function, and it tells us x is the number of months that the center has been open. So the first thing we want to know is after the center has been open for 3 months, how many people are recycling? So if it tells me the number of people is y and x is the number of months, if I have 3 months, do I plug that into x or y? X, yeah, because it says x is the number of months. So we just take 3 and we plug it in. So y equals 90 square root 3 times 3 plus 400. And so we want to know the number of people, which is y. Well, y is already by itself, so we just type that right on in our little calculators. So 90 square root of 3 times 3. And then to get outside of the square root, you hit over on your little arrows, plus 400. So we get 670 people. And that's it. Any questions on that? Okay, let's look at B. So B says, if 940 people are now recycling, how long has the center been open? So if I have 940 people, is people X or Y? Y. So this time we take 940 and we're plugging it into Y. Well, now we have to solve for x, and this is kind of what we were doing yesterday. So we want to get the square root by itself, so what should I do first? Good, subtract 400. So then we'll get 540 equals 90 square root of 3x. Then what's my next step? Good, divide. So divide both sides by 90. So what's 540 divided by 90? Good. So then we get 6 equals the square root of 3x. How do I get rid of the square root? Good, square it. So we square both sides. So on this side that gets rid of that square root. We know that 6 squared is, good, 36. So 36 equals 3x. And then what's my very last step? You got it. So x equals 12. 12 what? Months. Very good. Good, good, good. What if it said 1 year? Would that be fine? Yes. Good. Any questions on this one? Or else I got 2. So 2 says the period of a pendulum. And so period is the length it takes for the pendulum to make one complete swing. So a pendulum is like, you know, like a grandfather clock, how it has that little thing that hangs down with the little thing. That's the pendulum. So it says that's our T, and it's in seconds. Okay. So that is the time it takes to make one swing back and forth. So it's given by this formula. Again, it says our period is T, and then the pendulum length is L in feet. So we want to build a grandfather clock with a pendulum that swings back and forth every 3 seconds. How long would you make the pendulum? So I know 3 seconds. Is that going to be T or L? T, good, because T is our time in seconds. So we take that 3 and we plug it in. So 3 equals 2 pi square root of L divided by 32. Okay. So a little bit different because we have that pi there, but you know pi is just a number. So what could I do first to get the square root by itself? Yeah. So we divide both sides by 2 pi. So then the 2 cancels out, the pi cancels out. And then you can just type that in your calculator. 3 divided by 2. And then the pi is the second and the exponent button right below clear. And so we get 0.477. So now how do I get rid of the square root? Square. So we square both sides. That gets rid of that root. So 0.477 squared is a big, huge number. We'll just say 0.228 equals L divided by 32. So how would I get rid of divided by 32? Good. So then we multiply both sides by 32. And so we get L equals about 7.3 watts. So that's our length, and it tells us length is in feet. Good. Very good. Questions? Usually they're decimals, yeah. Ours look at 3. So 3 says the equation s equals 2 squared 5x can be used to estimate the speed, which is s, so speed is s, in miles per hour, given the length in feet, so length in feet is x, of the tire marks it leaves on the ground. A car that's traveling 90 miles an hour came to a sudden stop. According to the equation, how long would the tire marks be for this car? So we have 90 miles per hour. Do we plug that in for S or X? S. Good, because that's our speed. So 90 equals 2 square root of 5x. So how do I solve it? Good. Divide by 2. So then 45 equals square root of 5x. Then what? Good. Square both sides. 45 squared is what? Good. 2025 equals 5x. Good. Divide by 5. And we get 45 what? Good. Feet. Oh, Taylor. It's right there on the wall with the. Good. Any questions on that one? Alright, one more. Let's look at 4. So 4 says the speed that a tsunami can travel is given by this equation, where S is the speed in kilometers per hour, and D is the average depth of the water. Okay. So part A, we want to know what is the speed of tsunami when the average water depth is 0.512. So I've got the depth is 0.512. So do I plug that in for S or D? D. Good. So we want to know the speed, so we're trying to find S of 356 square root of 0.512. Well, on this one, our S is already by itself, so we can just type that in the calculator. So we get about 254.73. And what's our units? Good. Kilometers per hour. Very good. Questions? Let's look at part B. So part B says we want to solve the equation for D. So if I have S equals 356 square root of D, if I wanted to solve for D, what would be the first thing that we would do? We would divide. Well, I don't know what S is, so we'll just keep that a fraction. So S over 356 equals square root of D. And then what would be my last step? Good. Square both sides. So when we did that, the square would apply to both the S and the 356. So then I would say D equals, in parentheses, S over 356 squared. Now you could give that square to it and have S squared and 356 squared, but 356 squared is really big. So you can leave it or you can write it, don't matter. So the point of doing that is, if we look at part C, now it says a tsunami is traveling at 120 kilometers per hour. What's the average depth? Well, since we already solved for D, we could just plug in that 120 into this equation that we just found. And then we can just type that right on in our calculators. Oh. So if it gives you the fraction, you don't want the fraction, you can hit math and then number 2 and then that'll give you the decimal. So this one's at a depth of about 0.114 kilometers. So you don't have to solve, like we didn't have to solve for D. We could have still plugged in the S and solved like we did the other ones. It don't matter. Either way, you get the same answer. Questions.